about Newton's laws of motion. And so he made 3 laws, and we're going to be talking about all of them. So he published these laws in 1686 in a book called Principia Mathematica Philosophia Naturalis, and it's written in Latin. That's why it's so hard to read. And during those days, people wrote in Latin because it was taken more seriously. And so I'm going to first be talking about Newton's first law. So Newton's first law says that if you kick a ball, it should go on forever unless there is a force preventing it from doing so. And so if you do that right now, kick a ball, and let's say that it doesn't hit any object, then you will still see that it's stopping. And that's because there is still a force that's pushing. Have you guessed it? Well, it's friction and air resistance. And so air resistance is the resistance of the air, and friction is the resistance of a surface. And so where would you think we don't have any air or surface? Well, one good guess would be outer space. We don't have that there. So if we kick a ball there, what will happen? So let's just say this place is space. And so now it shouldn't stop, and there is no force right now. So when you kick it, it goes in the same velocity or same speed, and the same speed it had when you kicked it, and it will keep on that speed until it hits another object. Okay, now let's talk about Newton's second law. His second law states that F equals A times M, or mass, which is the weight of the object, times the force, times M times A, and force stands for F. So force is how much energy you use, and mass times acceleration, which is basically the change in speed. So mass times acceleration equals force. If force is the energy, acceleration is the change in speed, not the speed. Don't mistake it for that. And mass is the weight. So I'm going to have an example of Newton's second law in action. And so I have a circle and a square. And so the circle weighs 10 pounds and the square weighs 100 pounds. And now that we know the mass of them, we can substitute that in his equation. And now we need to know the acceleration. So the acceleration of it would be 9.8 meters per second squared. And that's just because gravity is accelerating the objects and not just throwing them down in the same speed. And you might be saying, how did I get 9.8 meters per second squared? And that's because if you throw any objects down, it will accelerate, and that means a change in its speed, at 9.8 meters per second squared. So it will go 9.8 and it will go faster and faster and faster at 9.8 meters per second squared. And so Galileo Galilei figured this out. And so every object this will happen. So if you throw elephants and mouses, they'll go at the same speed, 9.8 meters per second squared. So if we multiply this, the square force would be 980 newtons, and that's how we measure force. And the circles would be 98 newtons, since 10 times 9.8 is 98. And so now you can see that the square is hitting with more force, and this is why if you fall off a roof and a squirrel hits off from a roof, then the squirrel doesn't get injured because it has less impact force. It's getting hit. Its body is acting upon less force than your body is, because your body is hitting with 980, while its one is only 98. So it can probably bear the 98 newtons it's supposed to bear when it falls off the building. Well, you can't. Your body cannot bear the 980 newtons, and so your body breaks its bones, and that's why you have to go to the hospital when you do that. I recommend you don't do that. And now we have Newton's third law. His third law states that for every action there is a reaction. One good example would be rockets. So rockets, what they do is they propel some type of gas or water, whatever. You just propel it out of the combustion chamber. And the important part is you have to do it at very high velocity. So you hit it at very high velocity towards the earth. And so then the earth would push you up. And that's how rockets work. And I have another video more specialized on that, and you can watch that at kidsteachkids.org. And then I have also another example, and that will do with gravity. So if we have the ground and we have a triangle, and now the triangle is sitting on the ground, but shouldn't it be going towards the center of the earth? Because see, if you have heard of gravity, gravity pushes everything towards the center of the earth, or the core. And so then it should be going towards the center of the earth. So why is this not happening? Well, this is not happening, and the triangle is just staying on the ground because when gravity pushes the triangle, it's pushing its mass or weight towards the ground. And so the ground, as an action and a reaction, the ground pushes the triangle up. So this is how it does. So in the rocket, the action was it pushed things at high velocity, and the reaction was the rocket went up. At the triangle, the action was the triangle pushed its mass towards the ground. The reaction was that the ground pushed the triangle up enough to balance with gravity, not to push the triangle up to space, but just to balance it with gravity. Thank you for watching. I hope you enjoyed the video. Bye.